Welcome to video 1 of a 4-part video series concerning the National Water Model Learning Module found on Hyrolearn.org. My name is Easton Perkins. I am a BYU student and research assistant in the Hydroinformatics lab. Today we'll be going over how to do exercise number 1 found in the National Water Model Notebook number 1 titled Visualizing Forecasts in Python. To access the National Water Model Learning Module, type into your browser Hyrolearn.org. This will take you to the main Hyrolearn page where you'll search National Water Model. And simply click on the icon to access the learning module. If you've navigated to this point, you should be on a page similar to this one. This is the National Water Model Learning Module here on Hyrolearn.org. Here, it provides a brief overview of what the National Water Model is, how it came to be, why researchers in the past thought it very needful to have the National Water Model, and how it's progressed over time, and a bunch of learning activities that are going to allow us to understand the outputs of the National Water Model and exactly how we can apply them in our different research fields. This video assumes that you've already read through all of these, done the short quizzes, and have a brief understanding of what the National Water Model is, what it outputs, such as short range, medium range, and long range forecasts, and how to interact with those. This video tutorial is going to be here in learning activity number 2, accessing the National Water Model through Python code. The first page here will help you get set up with the Jupyter Hub notebooks. If you haven't done this yet, go through this page and make sure you understand how to access Hydroshare. At the very beginning of the module, you should have set up a Hydroshare account and joined the group. If you haven't done that, there's a YouTube video where I explain how to do that. And we are just going to jump right into it, assuming that you've already done this. So we're going to click on this link here, and we are going to access Jupyter Hub. Alrighty, and this is, if your page doesn't look exactly like this, that just means you're not in developer view. That's fine. You should see a bunch of links no matter what your page looks like. And one of them should say National Water Model 1, visualization, or visualizing the forecasts in Python. So click on that one. All right, and we are here. We have made it to our Python scripts. We're going to scroll right down here to the bottom of this learning activity, and we're going to come right to the exercises. This video is going to concentrate in on exercise number 1. Exercise number 1 states, create a plot of today's medium range forecast for the Mississippi River anywhere along the border between Missouri and Tennessee. Hint, you'll first need to get a reach ID, then create a time series, and then plot the time series. All right. Let's go ahead and get to it. If you feel confident or feel like you can give it a try, go do it. If not, we're going to walk through it right now. So we'll scroll right up here to the very top. As we know, code always runs from the top to the bottom. I'm going to provide a brief overview of what each cell does in our code. Very brief, but I do assume that you have already ridden through all of these explanations, ran through the code, and try to understand it for yourself. Some big code blocks like this can look really scary. I promise they're not. Just take time to read the explanations, and they'll make sense. So our first cell here, we're going to click on it. We're going to make sure you hit run. If you don't hit run, a number doesn't appear in the brackets there. Then that means the cell didn't run, and if the cell didn't run, that means that the exercise isn't going to work for you, so make sure it runs. But this first cell here is just importing all of our packages that we're going to need. So you have xarray to organize all the data that was taken from the national water model. Import matplotlib, that's a plotting tool that's very popular in Python. It's going to allow us to plot the data, and we're going to see all these things applied later on. Okay, we're going to come here. Pretty simple. The code's already written for us, so you're just going to hit run. And this, in as short amount of words as I can do, I'll try to explain what this is. It's basically just a code that goes out and grabs the URL depending on what reach ID we have in it, and with our start time, whether we want a short range forecast, medium range forecast, or a long range forecast, goes out and grabs the URL, recognizes what kind of forecast we want, and it gives us the data for that particular reach ID. If what I said right there doesn't make a lot of sense, go back to the learning module and read about short range, long range, and medium range forecasts, and try your best to understand them. So this is just going out, grabbing the data for us, the flow rates, and that's pretty much it for that. So we're going to come down here to matplotlib. As I explained earlier, it's just going to graph the data for us. So we're going to keep coming down here, and we get some variables. All right, so these are pretty simple. This is just setting up what we need. So we're just going to run here. It's just going to set up the variables, what we're going to call for the data. And right here is the meat and the potatoes of this exercise. This is all we really care about, as long as you hit run on all the previous cells. All right, so this activity is wanting, let's scroll back down here, make sure we do the right thing. We want a plot of today's medium range forecast of the Mississippi River anywhere between the border between Missouri and Tennessee. All right, so let's come back up here. So first thing we need is a stream ID. You might be asking what a stream ID is. A stream ID is basically like a barcode, but for sections of rivers throughout the continental United States. So we know for food products at a store, each food product has a barcode, and when we scan it, it identifies what it is we scan so it can charge us the right amount of money. The same thing goes for stream IDs for rivers in the continental United States. Basically, each stream ID is aligned with a certain portion of a river in the continental United States and is able to allow our code to identify exactly where we want the data to come from in the continental United States. And there are 2.7 million stream IDs or reaches of rivers throughout the continental United States. So our goal now is to go and get the correct stream ID to put right here. So we're going to come up here to this link, water.noaa.gov/map. Click on that. Wait for it to load. You should have played with this site a little bit in the first learning activity if you're going through the module. If you haven't, I'd go back and do learning activity number 1. It'll explain how to use this web application. Okay, so basically here are all the rivers and streams throughout the continental United States. The problem or the exercise we're working on wants between Missouri and Tennessee, so we'll come right in here. This I think is here we go. We got Missouri over here, Tennessee, and Mississippi River. Okay, so we can click anywhere along here. Let's click here. It doesn't matter. You click here if you want, wherever. You might be asking yourself why, when I click this portion, why doesn't it highlight the whole Mississippi River? The reason is because maybe you can see right here there's a stream coming in or out of it. I don't know which. And there should be one here. Yep, it's coming in or out of it. And because there's a stream coming in or out of the Mississippi River, it's going to change the flow rates for just this portion of river. So we need a different stream ID for this little section of river compared to this little section compared to this little section. So that's why. All right, so we're going to come over here And conveniently, we have a reach ID. So we're going to copy this, Control C. We're going to come back to our code, and we are, as simple as that, going to paste it in. All right, it's in there. We're going to leave this as today because the exercise asks for today's flow rates. We'll just keep that at 0, 0. It's fine. Medium range. If this didn't say medium range, you type in medium range, right? Remember that the medium range has several members to it, 1 to 7 members. So you can choose what member you do, but I'll just keep it at 1. That's fine. And we're good. So we're going to come up here and we're going to hit run. Now this will take a little while because it's going out to the National Water Model data, and it's getting the data for our stream ID that we put in, and it's grabbing all that data. You can see over here the data files coming in little by little, but it'll take a minute. So just be patient. All right, now once it works, you should see all these numbers down here, all the data brought in. That took my computer actually a while to do, so I paused the video for a minute, so don't be alarmed if it's taking forever. All right, now we're on the last step, plotting. We use matplotlib, and it has all the parameters for our graph, time, colors, and we'll just hit run. So just come down here and hit run. You can play around with this if you want to change the color, the line, the axis, maybe you don't want cubic meters per second. Actually, that's what the data is given in, so you have to have that. But you could change the title. You could do a lot of things, but I'll leave that for you to play with. But let's just look at our data real quick. So now that we have it plotted out, we can make a lot of observations about this graph, or the flow rates that are happening in this reach right now. So we can see that cubic meters per second. Okay, we got time. So right now it's at just under 19,500 cubic meters per second. It dips. It's going to dip in about 10-15 minutes, and then the flow rate's going to go up. So maybe a big rainstorm is going to happen pretty soon there, and the flow rates are going to go up. So this is pretty useful information. It's pretty awesome that we're able to plot it and are able to analyze exactly what's going on there in that river, in that little section of river at that in this very moment. Now keep in mind, when you do this, it's going to look different because of course you might have selected a different reach than I did, or you're going to be doing this a different day than I am, and maybe it's going to be in the middle of winter where flow rates are maybe not as high. Right now it's the spring, so lots of rain and snow runoffs and stuff like that. So just keep that in mind. Your graph will not look the same. But as long as you get the graph and you understand the process, you have completed the exercise. Last but not least, do not forget to run this little block of code. It's going to erase all the files that got downloaded so it doesn't fill up your Jupyter Hub notebook. All right, that's it for exercise number 1. Good luck.